compound interest. On this slide, I'm going to walk through the formula for compound interest. The P on the outside of the parentheses indicates the initial principal invested. So that's the initial amount that perhaps you're putting into the bank, or if we're talking about populations, it's the initial population. We could be talking about bacteria growth or decay, so it would be the initial population of the bacteria. So whatever you're starting with. Then the R value is the rate of change. So in this case, we're talking about the rate of interest. And notice that it's always written as a decimal. So you will convert it from a percentage to a decimal. The N value is the number of times we are compounding, and it is based on per year. So if we're compounding monthly, then the N value would be 12. If we're compounding semi-annually, the N value would be 2, and that information will be indicated in the question. The A value is what we're left with, so the population that we're left with, the bacteria that we're left with, the amount of money that we're left with, and notice that this is measured in years. In the first question, it says, in 2015, the population of a small town was 8,000. The population is increasing at a rate of 2.5% per year. Rewrite an exponential growth function to find the monthly growth rate. So a key word here is the monthly growth rate. Now remember, our formula is based on years, so we're going to have to adapt it a little bit. We start with setting up our formula. We have that 8,000, which is our initial population. Our annual growth, notice that we changed that 2.5% to be a decimal. And then we have the number of years after 2015, because in 2015 the population was 8,000. Then we have it simplified. We do have to convert this to months. To identify the monthly growth rate, you need the exponent to be the number of months in T years. So we haven't identified how many years because the question is just asking us to come up with the exponential growth function. We changed 12T over 12 just to indicate the number of months in a year. Here we change the power to a power, so we split that 12T over 12 and we separated it. So 1 over 12 went inside and it's attached to the rate, and then we have another 12T on the outside. So the reason that we're doing that is because the question is asking for the monthly rate, and in the question it was giving us the annual rate of 2.5%. If we simplify what's inside of the parentheses, we get approximately 1.00206. And since the question is asking us for that monthly rate, the 1 is built into the equation. So we actually subtract the 1 at the end to identify what the monthly rate is increasing by. So we're left with 0.206%. So we change that decimal back to a percentage to answer the question. The next question is talking about money. So we invest $5,000. So we're starting with that $5,000 and the rate is 4%. We will have to convert that to a decimal. How much will there be in the account after 3 years? If the interest is compounded annually, semi-annually, quarterly, and monthly. So that means that the value of N will be changing. Here's our first formula. The 5,000 is on the outside of the parentheses. We have 1, which is built into the formula, plus 0.04, or 4% as a decimal. we're left with 5,624.32 cents after 3 years. So that's our annually. So what's going to change is that 1 that you're seeing in red when we move to semi-annually. So the end value will change to 2. We don't get that much more money, but we do get a little bit more money. Quarterly will change to 4 times a year. And monthly will change to 12. The last type of interest formula we're going to look at is our compounded continuously. Now, our compounded continuously means that we're not just compounding once a year or twice a year, is that we're continuously compounding even on our interest. What you'll notice here is this E. What you need to understand is that this is actually a number. It's programmed into your calculator. The P is still representing that first initial amount that you're putting in. The R is the rate written as a decimal. And the T is our time. Use the information at the right. What is the total amount of money in the account if it's compounded continuously? So we're going to identify our variables and plug them into the equation. The value of the account after 8 years is approximately $4,974.47.